Why hello? All right, so we are going to start Unit 8. This is the last unit of the course. This is all about area and volume, but area and volume from a calculus perspective. You're going to be able to find area and volume for things that you never even dreamed of, or in some of your cases had nightmares about. It's going to go well. This is a very calculator active kind of unit, and there's also going to be a lot of calculator inactive skills going on, and we're going to strike a balance, and it's all going to be okay. Now, you may remember we've already talked about area in this class once before.
I don't remember.
It was a while ago. It was before spring break. There's this thing that we do in calculus, the definite integral. Like you guys know, oh my God, you know that when you see this thing here. Okay, first of all, how do we read this? Want to get some hands? How do you read this? Right. Oh, or we can do it all together. How do we read it? Okay. The definite integral of f of x with respect to x from x equals a to x equals b. This is area, right? But specifically, the area that we're talking about, if this is the graph of f of x, you might want to grab a marker. Here's the graph of f of x. Here's the vertical line x equals a. Here's the vertical line x equals b. The area that I'm looking for is that area over there. We've done this before. We've been here. We're okay. There once was a time you could only find these areas using your graphing calculator, right? We type it into the calculator, and the calculator spits out the answer. Those were not the dark times. And then we upped our skills, and we came to questions like this. Find the area bounded between the function f of x equals the square root of x, the x-axis, and the vertical lines x equals 1 and x equals 9. Just take a minute, let's clear those cobwebs off, go for it. See what you can do, we'll talk in a bit. Show me your shut up. Do the calculus, make me a proud papa.
You're asking for my boot back.
Find the area bounded between the function f of x equals the square root of x, the x-axis, and the vertical lines x equals 1 and x equals 9. I'm seeing people already off to a really good start. Not you. Okay, some people have sketched it and they said, okay, here's the square root of x, here's x equals 1, here's x equals 9, that's the area that I want. Your setup, it's going to be an integral of the square root of x with respect to x from 1 to 9. How many of y'all have this as your setup? Lots of folks. And you know what? That would earn you the first point already. Locked it in. Gonzalo, where do you go from here? How do you figure that out?
You change x square root of x to the 1/2.
You're going to rewrite square root of x as x to the 1/2. I agree, but why? Why are you going to rewrite square root of x as x to the half? What are you hoping to do here, Paul? You want to find the antiderivative, and if you rewrite square root of x as x to the half, there's a rule that we know. This is the power rule. And the power rule says, add 1 to the power, 1/2 plus 1, still 3/2. And then what? Add 1 to the power, it's been a while. Add 1 to the power, and then divide by that power. So 1 divided by 3/2 is 2/3. From 1 to 9. And for those of you that are still trucking along with me, once you find the antiderivative, that's usually the second point. Jeanette, do you remember how we're going to finish this off? What are we going to do?
You plug in 3 and 9.
Wait, 3 and 9?
1.
My handwriting's bad, not that bad. Okay, we're going to plug in
1.
the 1 and the 9. Which one first?
The x. You make that a wait.
Wait, you said we're going to plug in 1 and 9. I agree, but which one first?
9.
The 9. Right, big parentheses minus big parentheses. 2/3 times 9 to the 3/2 minus 2/3 times 1 to the 3/2. So hopefully everybody's okay. If it's free response, stop. But let's assume it's multiple choice. Jesus, how are you feeling about 9 to the 3/2 power? What is that? 9 to the 3/2 power. I know, I just put you on the spot. Remember, start in the denominator. So that means square root of 9, which is 80. Oh my God, spring break wasn't that long ago. Square root of 9 is 3. Okay. Then you go to the numerator. 3 cubed is 27. 2/3 of 27 is 18. We'll stop embarrassing. 1 to the 3/2. Square root of 1 is 1. 1 cubed is 1. Times 2/3 is 2/3. Now, for multiple choice, I need you to do stuff here.
Simplify.
Yeah, I need you to combine 18 and 2/3. Okay, if you're not sure, make it 18 over 1 minus 2/3, common denominator, 54/3 minus 2/3 is 52/3. Done. If we're talking about the free response part of the test, there you go. If we're talking about the multiple choice, you need to get to 52 over 3. And I would hope for the most part we're feeling comfortable with this. Henry.
How come we didn't plug in the 9 and the 1 into the new equation?
Why didn't we plug the 9 and the 1 into the new equation?
Yeah.
We did.
No, like, you know how we get like new numbers? Oh, no, into the original one? So I guess you put 9 in.
Oh, you never plug them into the original. It's after you find the antiderivative, that's when you evaluate the antiderivative. Antiderivative at the top limit minus the antiderivative at the bottom limit. Okay? This is just meant to be a review of stuff we did before. Now I want to start pushing you a little bit more. See what you can do with this next one. Find the area in the first quadrant bounded by the curve f of x equals negative x cubed plus 9x and the x-axis. Once you've completed the problem by hand, you can verify the results with your graphing calculator. I'm going to let you guys play around with this for a little bit, see what you can do. Fly, monkeys. Oh, I have high expectations.
Oh, is this first one?
Quadrant number 1, 2, 3, 4.
Whenever we have infinity, we do something. We do the this changes into the and then we do like that.
So, one of the things that I'm seeing is no one's actually bothered to sketch the graph.
I know it was Egyptian. I told her.
It was Egyptian? If you sketch the graph, there's going to be some clues there to help you out. I'll tell you, you are not going to integrate from 0 to infinity. In calculus BC, we integrate from 0 to infinity, and we call that an improper integral, because that's not what we do in AB. No one's got the graph. All right, let's I want to pause the action here a little bit. Does anybody remember anything from pre-calculus that might help you with this graph? Anything at all that you see here from pre-calculus?
What's that?
That math course you took last year, Jeanette, what do you remember?
The power rule tells you, well, not the power rule, but like the exponent tells you how many times the function jumps. Well,
How many
it
times the
crosses
function? Not jumps, but
Crosses the x-axis.
crosses the x-axis. It tells you the maximum number of crossings. So in this case, how many?
3.
3 crossings, 3 roots. That's the thing that we remember from pre-calculus. What else? There's something else. Rebecca?
You said
What are you doing? What's this thing? End behavior. We know stuff about end behavior. The degree is 3. So the ends point in the same direction or different directions?
different.
Okay, so ends point in different directions. So that means either, let's see, either this way
No.
or this way.
Yes.
Yeah, that
This way?
No. The other way.
The other way.
This way?
Yes.
Why?
Because it's negative.
Because the negative. Good. So the graph looks something. We know this and we know this. What we don't have, as Jeanette said, are the crossings, are the roots. Anybody know?
It's flipped.
Yeah, it's flipped. Just testing you. Monday after spring break, meet you. Okay. The only thing we don't have are the roots. How are we going to get the roots, Michelle? Right, we're going to say negative x cubed plus 9x, and we're going to set that equal to 0. And then we're going to let the pre-calculus and the algebra 2 skills come on out to play. Negative x cubed plus 9x, I might factor out the negative x, which leaves me x squared minus 9. X squared minus 9 is really x plus 3 times x minus 3. Where are my roots? X equals 0. X equals negative 3. And x equals 3. I've got a root over here at negative 3. I've got a root over here at 0. And I've got a root over here at 3. My sketch should look something. That's what the sketch looks like. Finish it from here. Everything you need is right there at your fingertips. Well, the problem said in the first quadrant. That's the only part of the graph that's in the first quadrant. That's the only part of the graph. All right, walked around, saw a lot of folks moving in a good direction. We're going to integrate the function negative x cubed plus 9x with respect to x. Limits of integration? 0 to 3. Because all I want is this part over here, not 0 to infinity. As I head out towards infinity, I'm below the x-axis. So now I'm going to integrate, and I'm going to get negative 1/4 x to the 4th, 9/2 x squared. We evaluate from 0 to 3. Big parentheses minus big parentheses, negative 1/4 times 3 to the 4th. 9/2 times 3 squared, negative 1/4, 0 to the 4th, 9/2, 0 squared. And let's just assume that this is the free response. We're not going to simplify. Is everybody mostly okay? We've been here, we've done this. Maybe it's been a while. If I was going to award points, probably 1 point for the setup, and I'd offer another point for getting the limits of integration, because those are a little bit tricky. Another point for the antiderivative, and then final point for the evaluation. So it'd be worth 4 points. That's where we've been. Now let's talk about where we're going. No, it's going to be okay. It's going to be okay. Where we're going is we are going to look at area bounded by 2 curves, or 3 curves. or more curves?
No curve.
Why bother with just one curve? We're out of the baby end of the swimming pool. I want to push you further. Some of you I want to push a lot. Adrian, man, when I think about pushing, I think about pushing you. Oh, do I want to push you? Okay. On page 6, for those of you that need like a step-by-step process, give it a read. Give it a read. Oh, I want to push Adrian. I think about pushing Adrian. Great. Down the stairs. Push, push, push. Let's give it a whirl. Find the total area bounded by the curves f of x equals negative 2x squared plus 3 and g of x equals negative x plus 2. You might want to grab the markers out of the supply kit, because I'll tell you, with all of these problems that we're going to look at, you need to understand what area you're looking for before you just spring into action and like mess the whole thing up. And for this first one, I wanted to be kind. I wanted to give you guys graphs that we should know and know well. For example, the graph of negative 2x squared plus 3. What do we know? Parabola. Opening which way?
Down.
Down. What do we know about the vertex? Oh.
Wow, y is 3. That's what
Okay. It's a point. So there's an x and there's a y. The vertex is at 0, 3, and the graph opens down. That's f of x. Now we've got g of x. G of x is negative x plus 2. What about that graph?
Isn't that a linear function?
That's a linear function. That's a line. And it passes through the point 0, 2. And I've got negative slope. So the graph looks something like that. Now, this is where things are going to be different. What's the area that you're looking for? Once you get this sketch, point to it so I know that we're all on the same page. What's the area that you're looking for? God bless. Find the total area bounded by the curves f of x equals negative 2x squared plus 3 and g of x equals negative x plus 2. Okay, we're looking good.
Yeah. Or is it
It's got to be bounded, which means trapped. Trapped like you feel in here sometimes.
I know.
Bounded by the parabola and the line. So some people have shaded in like this little, like almost triangular piece. Diego doesn't seem to like that part. Diego, why not?
I'm guessing they're thinking the axis is a line.
Okay, so they're reading into this x-axis as one of the bounds. Not true. I'm not talking about the x-axis anymore. What are the bounds? Where's like the fence that like chains you in here?
Oh, is it GX? Like the new fence?
Find the total area bounded by f of x, the parabola, and the line. The region that's bounded by that is this section here. Right? Otherwise, if you go like down here, well, the only way you're going to get bounded area is you need the parabola, you need the line, and you would need the x-axis. That's not what I'm asking for. You got to make sure you read this carefully. Now, automatically, I hope we see what's different. What's different?
It just looks different.
It looks different. Why does it look different?
There's usually just one graph and like the entire bottom.
It's one graph and the entire bottom? I don't know about that. Marilyn?
Because you have like different, but like we don't have the x-axis anymore.
You don't have the x-axis anymore, so that's missing. Paul, what else is different?
No, I was going to say that. How are you going to integrate with respect to x if you don't use the x-axis?
How are you going to integrate with respect to x if you don't know the x-axis? That's good, Karina.
It's in the second and first quadrant.
Now we're in the first quadrant and the second quadrant, Daisy.
I was gonna say, like, if you want to try to find like the area by the shape, we can't because we don't know what shape it is.
You can't just say, oh, I know what the name of the shape is, because we don't. Everybody okay? So, all right, so some thoughts on this. I might say, okay, well, if I'm going to do an integral, right, because we always find an area with an integral, I need a starting point and I need an ending point. Where do I start? Where do I finish?
I think the intersection.
The important thing is the intersection points. Wherever the graphs intersect, that's where I'm going to start integrating, and this is where I'm going to end integrating. So if I want to get the intersection points, you guys know how to find intersection points.
Is that interactive?
Nope.
When f of x equals g of x.
What we need is for f of x to be equal to g of x. So f of x is negative 2x squared plus 3. G of x is negative x plus 2. I'm looking for the intersection. I'm looking to see where they're equal. Well, I need some algebra skills here.
Add x.
You could add x, sure. Negative 2x squared plus x. You could maybe subtract 2. So you get negative 2x squared plus x plus 1 equals 0. Why are we doing that? You want to find the roots, and the way that you find the roots is you figure out where this guy's equal to 0. So maybe you're going to do a little x box. Okay? You can do the x box if you need to. So we're looking for what multiplies, let's see, negative 2, but adds up to positive 1. And that should be positive 2 and negative 1. If you're going to do your box, negative 2x squared and positive 1. We need 2x and a negative 1x. I know I'm going fast. This is just algebra stuff. Factor out the negative 1 here. Negative 2x minus 1 times x minus 1 is equal to 0. Set each one of these equal to 0. And solve. Okay. I know I'm going fast, but that's just Algebra 1, Algebra 2 stuff. So what we know now are your limits. What you don't have is the integrand. What is it that we're going to put here? What are we integrating? What function? Is it f of x? Is it g of x? We need to get clever here. Sheila, what clever thoughts do you have for me?
Isn't it both because it says the total area between those?
We definitely want the area bounded between the two, and we're going to have to be clever here. Because look what happens. If you say integrate f of x, well, what does that mean? That means the area from negative a half to 1 bounded by f of x and the x-axis. So what that would tell you, look at all these hints. Give me just a second. If what you do is you integrate f of x, it's going to say find this area and that area there. I don't want that too much area. So what clever thing can you do here, Jackie?
Couldn't you use that when we figured out if it negative 2x to the power of 2 plus x plus 1?
Yes, I don't want to go straight there yet. I don't want to go straight there yet. If we just use f of x, you're saying from negative a half to 1, everything below the parabola, and you're catching this area that you don't want. So Daisy, what are we going to do?
When you subtract g of x from f of x?
If you subtract g of x, now what you're saying is this area down here that you don't want, throw it away. Subtract it off. So what we're looking at is f of x minus g of x, integrating that with respect to x. That's where we are. Take a minute, see what you can do to finish this off. Yeah. Not f of x with respect to g of x now. You could do the integral of f of x with respect to x, and then minus this other one. Do like two different integrals. That would be a possibility. Alright, so we're going to integrate from -1/2 to 1. F of x is negative 2x squared plus 3 minus g of x with respect to x. Gosh, that's ugly. Maybe we can clean this up a little bit. And Jackie, I think this kind of gets to your point earlier. Negative 2x squared plus 3 minus all this, when you simplify, becomes negative 2x squared plus x plus 1. And you integrate with respect to x. F of x minus g of x. See what you can do. So over here, it looks like you're loading integrator. So don't use that. Use the vertical one instead. All right, integral of negative 2x squared is negative 2/3 x cubed plus the integral of x is 1/2 x squared plus the integral of 1 is x. You evaluate from -1/2 to 1. Big parentheses, negative 2 times 1 cubed plus 1/2 of 1 squared plus 1 minus big parentheses, negative 2/3 times -1/2 cubed plus 1/2 of -1/2 squared plus -1/2. Once you get the setup going, -2/3. Thank you for that. Thanks, Jackie. Once you get the setup and you get your limits of integration, hopefully the calculus part isn't too bad, right? We're just going to use the power rule. We're going to plug in the simplification would be ugly, much uglier than I want us to worry about right now. I don't want to beat you down with fractions.
So for your response, what would you do?
Let's assume it's the free response. Questions so far? I'll take anything from anybody. Something that you're curious about, something you're worried about. Destiny.
So when it's asking about two graphs, you always have to subtract it, or it depends on how the graph is?
It's going to depend on the graphs, and this is where I'm really going to need you to use your geometry knowledge to think through the policy. Damn it. Trust me, you're going to be okay. So Destiny, with that, I didn't mention this earlier, but I want to introduce you guys to this idea called the representative rectangle, and this is going to help. Or the representative slice. Remember when we used to do area, we would do let me sketch it over here. Here's f of x from A to B. And what did Riemann tell us to do?
Rectangle.
He said rectangles, right? Riemann, oh, who's that? Right, Riemann said do rectangles. And the way that you find the area of a rectangle is you say how wide is it? That's the delta x. And then you also ask the question, how tall? Because you were going from the x-axis up to the curve, it was always f of x. So your area always looked like an integral of length times width from a place to a place. Rectangles. We still want rectangles here. The difference is that when you draw your rectangle, it doesn't go down to the x-axis. Your representative rectangle, your representative slice, where does it start? It starts in the bottom function. Where does it end? It ends on the top function. How long is that slice is the question I'm really interested in. How long is the slice?
1.
Not 1.
3.
Not 3 even. I think, Janet, you said 1. Were you looking like between these 2 points? If I sliced here, the distance is 1. But if I slice over here, or I slice over here, when I do my slicing, I'm always starting on the top function, and I'm ending on the bottom function, and in geometry, the way that you find distance is you do top minus bottom. So f of x minus g of x. We're going to play around with this more. We've got about 15 minutes, which is perfect. What I want to do is I want to switch over to some calculator active questions. I want to grow your skills. Paul, how do you feel about driving? My advice with all of these questions is going to be, before you do anything else, sketch the graph. Make sure you understand the region that we're interested in, and use that calculator as much as you can.
And a hand.
Is that a table?
What's the difference, like, in the menu, it comes up, like, to find the interval, like, in the little box things. But then there's one that's like this, the regular one.
Okay, get those graphs on your calculator. Oh, how do you get rid of the slope field? Good question. Because that's probably the last thing that your calculator was set on. Okay, you go to the graph and you hit menu. And it's the graph, oh, what's the slope field? It says graph entry edit. Switch back to function. All right, and Paul, the graph that we're looking at here, it's good. It's got a little bit more going on than what you see on the paper. Let's get rid of this stuff. So I'm already using a scale. Let's go -5 to 5 for the x and -5 to 5 for the y. And my advice for all the friends who are new to this, once you've got this graph, make sure you know the region that you're looking for. What's the region that you're looking for the area? You have to be bounded, you have to be trapped by f of x, g of x, and the y-axis. Good, okay, do me a favor, sketch it on the paper so I know that you know what you're looking at. Adrian's got it, Karina's got it, f of x, g of x, and the y-axis. Where are you looking? What's bounded by f of x, g of x, and the y-axis? Bounded means trapped. It's going to be bounded on all the sides. F of x, g of x, and the y-axis. Good. F of x, g of x, and the y-axis. If all goes well, the region that we're looking at should be that one. That's the one. Now, how am I going to get the area? Well, area is obviously going to be an integral. First conversation that we need to have is, what are your limits of integration? Where do you start? Where do you end? Hopefully the start is easy. Where do we start? 0. Everybody okay? We're going to start at x equals 0?
Yeah.
Okay. So we're going to start at x equals 0. Where do we end?
The intersection.
3.
3.
It's not 3.
Oh.
2 point something.
2 point something. Is everybody okay? We need the intersection point?
Yeah.
Okay, now you've got the calculator. Let the calculator do the work here. So menu, analyze graph, intersection. According to Paul, 2.841. Make sure you can get 2.841 to show up on your screen. That means I'm going to integrate to 2.841. Now here's the thing. I want to grow your calculator skills a little bit here. We need to use this 2.841 in the calculations, so save it. Store the 2.841. If you don't remember how to do that, going over and you're going to click on this once, one time, so you highlight, and then your next button, not tab, var, var. It's above the 9. And then store var, and then save it as something.
Save it back up.
Anything you want. Don't use X. That's bad. That's take. Paul, what did you save it as? You saved it as Paul? Okay, so P, somewhere on your paper, just write that P is 2.841, or R is 2.841, or A is 2.841. And then once you've done that, that's your upper limit. We know we're doing an integral. We're going from 0 to P, and everybody's okay? Next thing, though, what are you integrating?
Fx minus gx.
Think about the slice. When you do your slice, when you make your rectangle, how tall is that slice? How tall? Now, some people are saying 4. I think they're thinking about the one slice maybe that's over here.
You make my sense.
Be careful. Which function's on top and which one's on the bottom?
You make
Look at your graphs again. Which one's which?
Gx is on top.
G of x is the one that's on top in this case. So G of x is the guy that's on top. The one on the bottom is f of x. So your integrand is G of x minus f of x. Integrate with respect to x. Paul.
So if the rectangle is getting bigger, you add?
Nope. We'll talk about that in a little bit. Dividend k G of x minus f of x. Top minus bottom. Top minus bottom, top minus bottom, top minus bottom. Whatever one's on top minus the bottom. Now how we're going to integrate this? On the calculator active part of the test. Oh my God, you're just going to type this in the calculator and the calculator does all the work. You get all that work. Paul, just make sure that we know what we're doing here. Oh, Paul.
No, wait.
Hit escape. Let's switch back. Oh, Paul. Oh, Paul. Okay. Go back to the calculate part of the screen. Menu. Calculus. For your favorite class. Shut up. Numerical integral. Put in your limits. We're going from 0 to P.
It's A, right?
A. P for Paul. Paul's actually going to type in Paul. I don't know if you were able to save it as Paul. Try it. I'm curious to see what's going to happen. If it changes to bold, you saved it as Paul. Nope, you didn't. So Paul just typed 2.841. Now make sure you get the functions right here. Top minus bottom. G minus F. You probably typed F in as F1 and G in as F2. Get those right.
Would it be F1 of X, right?
F1 of X, F2 of X. Okay, one more time, Paul. If the graph's not the same, something going wrong. Oh, that's 5 minus e to the x over 2.
Oh, I think that
So, oh, it did save. F2 of x minus f. We're not going to save things as Paul anymore. Oh, Paul. There you go. Okay, and according to Paul's calculation, 6.819.
Yes, sir.
How many guys have 6.819? Nice. Move on. Keep going. Seriously, on the calculator active part of the test, this is all I need you to do. Use that calculator for every single thing. Don't do the work by hand. I don't want to see that. I know what it looks like. It's bad.
Yeah, what if you went out of letters to put like whereas how do you do?
You can do menu, actions, and clear history, and that should wipe everything out. You can also, Gonzalo, you can just save it again. So like, you save it as A. Some people save it as A every single time, and it just rewrites over the A. Okay. Determine the total area bounded between the curves f of x equals tangent x over 4, g of x equals 5 minus e to the x over 2 on the interval 1 to 4. From 1 to 4?
Wait, let's see. How you gotta do that? Wait,
Wouldn't it be
1 to 4.
Trust your instincts. I'm seeing some good stuff here. You're going from 1 to 4. How on earth are you going to find this area?
I do think that you say it.
The good news is just about everybody seems to have found the regions that we're looking for. 2 different regions. Trust those instincts. You got some good ones. I was there. We're going to need an integral.
Whenever we add it, so this is 6.819 plus the integral from. Nope.
You have to do it.
Yeah.
You have the intersection.
All right, most folks seem to have figured this out. 2 integrals this time. 1 for each region. Sylvia, how do you feel about your first integral? Where do you start? Where do you end? I think some people are saying, okay, like here's region 1, and here's region 2. Tell me about region 1, Sylvia. Where are we going to start?
1.
You're going to start at 1. Where are you going to end? You're going to end at P, or A, or whatever it is. You're going to end at the intersection point. So we're going to integrate from 1 to P. Now be careful, when you do your slice, that rectangular representative slice, how tall is it if you're in region 1? In region 1, how do you determine the height?
Do you know if x minus f?
Is everybody okay that this is going to be g of x minus f of x? Okay, so we're going to integrate g of x minus f of x with respect to x. That's the area. That's the area for region number 1. How do I find the area for region number 2? Axel, how are you feeling about region number 2?
From P to 4.
Okay, we're going to integrate from P to 4. I agree, you've got the start and the end. Now tell me about your slice. How tall are your slices here? It's always top minus bottom. So how tall is this going to be? One more time. This one is f of x minus g of x. F of x minus g of x. You're going to integrate that with respect to x, and when you're done, when you found the area of the second region, what are we going to do? You're going to add those 2 together. And you know what the good news? Your calculator can do all of that in 1 step. I don't need to see the number here, followed by the number here. I need to see this, and then just pop it in the calculator. Finish it off. Give me a number.
46 plus 7.5.
Okay, if all goes well, according to my calculations, I don't have it. Oh, I do. I've got 5.303.
Yeah.
5.303.
Yeah.
5.303, and that's what Paul's getting eventually. 2 nights homework. I think I forgot to mention it earlier. It's assignment 118. It's just area problems like this one. Some calculator active, some calculator inactive. Follow the instructions. It's all going to be okay. Kevin, did you get one of the packets? Yeah.
I'm not gonna do these. I don't even know.
Refresh it.